Let's see if we can use Pascal's principle to analyze the braking force that we get from this hydraulic braking system. We put in some input force with our foot on a pedal, and we have some mechanical advantage with the lever on the pedal to increase that force fivefold. So we get 100 newtons coming in, results in 500 newtons actually being applied to the pedal cylinder. Now we want to know, for that pedal cylinder, that transmits some force into our hydraulic system, increasing the pressure in there, and then that exerts some output force on the wheel cylinders. We want to know, what is that output force? All right, we've already taken account of the mechanical advantage out here from the lever, so we'll start with 500 newtons as our input force, and we'll try and find our output force. The diameters of the different cylinders are 0.5 centimeters and 2.5 centimeters. This makes sense that we have a larger output diameter than input diameter because we want to get larger output force than our input force. We can find the radius by taking the diameter divided by 2, and we can do that for both input and output cylinders, resulting in 0.25 centimeters and 1.25 centimeters for the radii. Now we want to find our output force, and we'll use Pascal's principle that says that that pressure on the input has to equal the pressure on the output. We'll substitute in pressure as force over area and say that that's the force of the input divided by the area of the input, and that has to equal the force of the output divided by the area of the output. We'll solve for the output force, which is what we want. Now we have to figure out what these areas are. The area of a circle is pi r squared. We have the radius over here, so we can plug in pi r2 squared over pi r1 squared times f1. The pi's will cancel, so we can just consider the radiuses, the radii, as we calculate this, and we end up with an output force of 12,500 newtons. That's kind of crazy if you think about it, that the foot put in 100 newtons, we used some mechanical advantage to get it up to 500 newtons, and then we used Pascal's principle to boost that all the way up to 12,500 newtons. And luckily, we don't have to move those brakes very far to do what we want to do with them, which is slow down the wheels.